Hey guys, welcome to Trucks. Well, we finally have the front suspension mounts nailed down and welded in where they're supposed to be on the frame for Project Rolling Thunder. And we want to show you all that. But we've done some other stuff as well. We've relocated some mounts, added some boxing and some gussets, and just kind of did some more finishing work on the frame, meaning we're just about ready to add some parts to this thing. But we want to show you everything first. Now, we had to make a pretty serious relief cut in the frame rail for the upper control arm on the independent rear suspension. And that just didn't leave a whole lot of frame rail left, so we boxed it in to add some strength. Now, this rear section of frame rail, well, it doesn't have to be that strong, but we still wanted it as stiff as possible. So we added this 1/8-inch thick reinforcing plate. It's got a complete perimeter weld, rosette welds, and we contoured it to fit the frame rail. It's also got fish mouths at both ends. Now, the reason for the fish mouth is twofold. It not only gives you more area to weld to, making it stronger, but it eliminates a straight seam with stronger metal on one side and weaker metal on the other. If you did it that way, well, it'd only make the metal easier to fatigue and crack. Now, the name, well, it's pretty obvious. Looks just like a fish mouth. And this one looks like a carp with an underbite. And this one here is definitely a hungry largemouth bass. Now, we told you before we were going to have to build a new transmission crossmember for our T56 Magnum 6-speed. We also told you we didn't want it hanging below the frame rails. And we've got a gusseted pad for our polyurethane transmission mount. We used a piece of DOM tubing, a dimple-dyed gusset for strength, and we welded a bracket directly to the frame rail that will allow the crossmember to bolt in and be removable. And since it ties the two frame rails together, well, it's going to add some strength as well. Now, our new 4.6 kind of has this giant blower sitting on top of it. So we wanted to lower our engine and transmission down into the frame rails about 3/4 of an inch for hood clearance, because we want to keep the stock hood. And that meant new engine mounts and a relief cut and boxing of the crossmember for oil pan clearance. We've got about a 1/2 inch in between the pan and the crossmember. Now, we also boxed in the relief cut we made on the frame for manifold clearance. Now, there's no two ways about it. Designing a completely custom suspension system that works well is a challenge, and that's an understatement. In fact, these control arm mounts that you're looking at, well, that's version 2.0. The first edition worked great on the computer and in theory, but when it came time to applying it to our pickup truck frame, well, it just didn't work out so well. The steering rack was hitting the crossmember, the oil filter, you name it. It just flat out wasn't going to work. So what we ended up doing was putting the steering rack where it would work and designing the rest of the control arm pickup points around it. Now, the lower control arm mounts are made out of 1/4-inch thick steel and welded solidly to the frame. The lower arms are from Factory 5 Racing and fit a Mustang. The upper mounts have 2 holes for adjustability. They're made out of 3/16 plate and attach the circle track upper A-arms. Now, we had to ditch our stock Ranger rack and pinion. When we built our custom front suspension, we built it to match the increased track width of our independent rear suspension out of an 04 Mustang Cobra. So bottom line, the Ranger rack just wasn't wide enough. So we picked up a steering rack from a late model Mustang to suit our needs. Now, our steering rack bushings came from Maximum Motorsports, and they're solid anodized aluminum. They offer multiple mounting positions, so we can try to dial out any bump steer, or we can move the rack slightly if we've got any slight clearance issues. Now, since they're solid bushings, well, we're going to get all the feedback that the road's going to give us. But that's a good thing on a performance truck like this. And the trade-off for a little bit of extra noise and vibration is well worth it. For tie rod ends, we're going to try to get away with using these Mustang ends. But if need be, we can upgrade to an adjustable rod end later. Now, when we were planning the front suspension, one of our goals was to minimize bump steer. Now, in case you're not too familiar with what bump steer is, here's a brief explanation. It's what happens when the suspension and steering linkages move in different arcs. When that happens, when the suspension compresses, it can actually induce unwanted steering into the front wheels. Not what you want. Now, this is more suspension travel than our truck will ever see, but it clearly shows a change in steering without any input from the driver. Now, what we're going to do to minimize bump steer on our truck is to make sure that the pivot points of the inner and outer tie rod ends line up with the pivot points of the lower control arm, both at the frame and out at the spindle. Now, if we can't get the steering linkage and control arms to move in a parallel arc by adjusting the rack bushings, well, we'll just pick up a bump steer kit for the outer tie rod end. And that way we can change the height of the pivot point of the tie rod and get our pickup truck to handle as predictably as possible.
Yep. There it is. Hey, welcome back to Trucks. Well, now with the front suspension done, we can lower the engine and transmission into our relocated mounts and get this thing a little closer to a more complete rolling chassis.
Now, our front suspension is nearly complete, but we still got to pick out a front sway bar and coilovers for all four corners. Now, like we told you earlier, suspension design and geometry is a very complex subject because there's so many things to consider. Steering axis inclination, camber gain, caster trail, bump steer, roll center, scrub radius, and Ackerman angle, just to name a few. So needless to say, it's complex, and it's nice to have an expert kind of check your work when you're doing something like this. And that guy for us was Jack Hidley at Maximum Motorsports. He's been immensely helpful in making sure that this is done correctly. So whether you're doing something like this, or rebuilding your first engine, or laying down your very first paint job, it's always nice to have an expert in the field to kind of help you through the process. Now, speaking of Ackerman angle, that's the reason why we had to redesign our original front suspension setup. There just wasn't enough Ackerman angle built into the steering, but we've got that all taken care of now. And if you're not familiar with the term Ackerman angle, well, here's what it is. Now, if you drew an imaginary line perpendicular to each front wheel while it's turning, and they intersected on a line drawn straight out from the rear axle center line, you would have 100% Ackerman or geometrically perfect Ackerman steering, meaning that the outside tire is going to follow a larger arc or a larger circle than the inside tire, allowing the vehicle to pivot around the corner without these two front tires fighting each other. Now, if the steering tires were parallel and they followed the same large arc, well, they'd be fighting each other for traction as you went through the corner, causing tire scrub and other unwanted handling characteristics. Now that we know that, well, there's two different schools of thought on how much Ackerman angle you need built into the steering of a race car, due to the outside tire handling the vast majority of the cornering load, and the inside tire kind of being along for the ride. But we're not building a race car. We're building a fast street truck that we can take to the track. And making sure we have the appropriate amount of Ackerman angle built into our steering will ensure that our truck handles great on the street and at the track.
Now, the front suspension system is a mixture of aftermarket and original equipment components, like these front seal bearing hubs that are spec'd for an SN95 Mustang. Now, they're easy to replace and inexpensive, and also support aftermarket brake upgrades, like these Brembo 13-inch rotors with 4-piston calipers that we got out of the Ford Racing catalog. Because at the end of every straightaway is a curve or a retaining wall that we frankly do not want to come into contact with. And the last piece of the drivetrain puzzle is the driveshaft. Now, a great way to reduce weight and parasitic drag at the same time is with an aluminum drive shaft. So we called Denny's Driveshaft service and had him make us up this one. It's his 1350 series high-speed balanced 4-inch aluminum shaft and features Spicer 1350 series U-joints and this forged Spicer slip yoke. Now, we told Denny we were going to be pushing about 600 horsepower out of the back of this transmission, and we needed a shaft that would handle it. Well, he built us one that would take double that punishment. So it doesn't matter what you're building or what you're building it for. Go to Denny's Driveshaft's website. He's got all the forms and all the information that you need to submit an order for a drive shaft that can handle anything you can throw at it. Hey, welcome back. Well, you guys knew that we had a Rick's fuel cell that we were going to put behind the rear axle. We didn't know exactly where until we mounted the IRS cradle. Now that that's done, Ryan has done a nice job of installing some captured nuts on the inside of the frame rail, so we've got a way to lock it down. Now, Rick's also sent us some 90-degree angle brackets, so we've TIG welded to the sides of the fuel tank. That way, we can locate this thing exactly where we want it. Now, we also told the team at Rick's that we wanted the filler neck centered in the gas tank. That way, we can route it up through the bed floor and use a flush-mounted filler cap. We're also going to take advantage of the vacant real estate in front of the IRS cradle by mounting our battery and our coolant reservoir for the supercharger back here. Now, battery, typical hot rod stuff, we get it out from under the engine compartment and closer to the rear axle to help with weight distribution. The coolant reservoir is going to help us in a couple of different ways. Number one, it's going to be a larger capacity than the factory unit, and with the distance between the tank and the supercharger, we get better heat dissipation, better cooling, cooler running temperatures, more power. We made some calculations to show you guys what kind of difference you can make just by rearranging some of these components. The fuel tank itself weighs 54 pounds. 16 gallons of fuel at 6 pounds per gallon weighs an extra 96 pounds. This gives us an extra 150 pounds behind the rear axle. Now, our battery is going to weigh 45 pounds. Our coolant reservoir is about 20 pounds, and we picked up an extra 100 pounds just with the IRS cradle. That gives us a redistributed 315 pounds over and behind the rear axle. Now, you combine that with what Ryan's doing with the front end, lowering the roll center, stretching the wheelbase, well, that's getting us closer and closer to that 50-50 weight distribution we're dreaming about. Now, we want to create some protection for the fuel tank, just in case somebody runs into the back of this truck on the street, or in case sometime on the track it swaps ends and heads for a barrier. So we're going to build a protective cage around the fuel cell.
Now, this protective hoop is just 1 3/4 120 wall DOM that we bent up using our JD squared bender. Now, we designed it to sit rearward of the tank and lower than the tank. That way, like Kevin said, it'll protect the back and the bottom. After all, we don't want to scar up all the nice stainless steel. This truck is going to sit pretty low. And after mocking things up on the frame rail, we cut it loose so we can do the final welding on the floor. Then, after cleaning up the frame rails for a good clean weld, we tacked it in place again. Then we removed the fuel tank so we could get this little project finished up. Watch your fingers.
Perfect.
A Lakewood Driveshaft safety loop is another part we're eventually going to be installing. And if you're doing some racing, well, it may even be required by the sanctioning body. It's a universal fit, will fit a variety of different cross members or frame rails, and with it being made out of thick 1/4-inch steel, well, it's more than capable of containing the drive shaft in the unlikely event of a U-joint or drive shaft failure. The last thing you want is some 5-foot drive shaft finding its way up through the floorboard unexpectedly.
You're watching Trucks. For a DVD copy of this episode, just go to PowerBlockTV.com and order your copy for just $5.95 plus shipping and handling. Start your own Trucks collection, delivered right to your door from the Power Block.
Hey guys, welcome back to the shop. Well, Project Rolling Thunder is coming along nicely. We got our complete drivetrain installed, and the body is back on the frame where it belongs. And this truck's sitting at ride height too. And I gotta tell you, I think it looks downright aggressive. We're both really happy with the way this thing is turning out. Now, the pegs you see holding the frame up at ride height are gonna go away as soon as we can get our hands on some coilovers. For now, we're just happy that the suspension is basically done. And from this angle, well, looks pretty good. But from this angle, it's pretty clear we'd have a major tire rub if we don't do something about this fender. Now, I guess we could come in here and make a relief cut and bring this arch more towards the front. But we've got another problem as well. And it's this ½ acre of real estate in between the tire and the rear of the fender. Now the reason for that is that we moved the front axle center line forward 5 inches from here to here. Now we were originally going to go forward 1.5 inches and not do any body work. But if you remember, we had to build the front suspension around a suitable steering rack location. But there's another benefit to that. Now we've got 90% of the engine and all its weight behind the front axle center line, helping us with the weight balance. Now I guess it's up to Kevin to come in here and work some metal magic and try to get this straightened out. And whatever he does and comes up with, well, I'm sure it'll be functional and look good. Now it's no secret that turbochargers get good and hot, and the hardware used to secure them to the manifold goes through a ton of thermal cycling. So to prevent that hardware from loosening up over time, we're going to use Stage 8 lock-in fasteners to hold our turbo in place. First, the groove lock nut gets installed and tightened down on the manifold stud. Follow that with the retainer, making sure it's indexed and making contact with part of the turbo so it can't back off. Hold everything in place with the spring clip. But they also make a variety of hardware for different industries and applications, like these railroad parts and fasteners for heavy equipment and manufacturing. Heck, Stage 8 locking fasteners are even found on the space shuttle. And they play a part in helping bring the crew home safe.
Now, if you've got a manually shifted vehicle, especially a high-performance vehicle, you may want to think about Royal Purple's Synchromax for your gearbox. Synchromax is fully synthetic with additives that help reduce wear, free up horsepower, and keep your transmission temps cooler. But your transmission's not the only component in your vehicle with moving parts that need lubrication. For your differential, check out Royal Purple's Max Gear. This is a fully synthetic, non-corrosive, and race-proven formula that also contains the limited slip additive, so you don't need any additional products. So whatever you need for your drivetrain, Royal Purple has got you covered. Hey, thanks for watching Trucks. See you guys next time.